Download this code from codegive.com, link in the description below. Blending modes, a deep dive for video and film, including code examples. Blending modes are a cornerstone of visual effects, compositing, and creative image manipulation, whether you're working in Adobe After Effects, Premiere Pro, or even a scripting language like Python with image processing libraries. This comprehensive tutorial will explain blending modes from the ground up, covering their core principles, behavior, practical applications in video and film, specific examples using Adobe tools and filmriot techniques, and even a taste of how to recreate some blending effects with code. What are blending modes? At their heart, blending modes are mathematical operations that determine how the color of one layer, the blend layer, interacts with the color of the layer, beneath it, the base layer. They control how pixels are combined, resulting in a new color value for each pixel in the final image. Think of it like mixing paint, different ratios and types of paint yield different results. Blending modes provide a structured and predictable way to achieve these mixing effects in the digital realm. 2. The anatomy of a pixel, color channels. Before diving into specific blending modes, let's revisit the fundamental color models. In digital imagery, colors are often represented using the RGB, red, green, blue, color model. Each pixel in an image has a red, green, and blue value, typically ranging from 0 to 255, or 0.0 to 1.0 in a normalized floating point representation. These values represent the intensity of each color component. For example, asterisk, 255, 0, 0, pure red. Asterisk, 0, 255, 0, pure green. Asterisk, 0, 0, 255, pure blue. Asterisk, 255, 255, 255, white. Asterisk, 0, 0, 0, black. Additionally, many images include an alpha channel. The alpha channel represents the pixel's transparency or opacity. A value of 0 means the pixel is completely transparent, while a value of 255, or 1.0, means it's completely opaque. 3. The core math, blending mode formulas. Blending modes work by performing mathematical operations on the RGB, and often alpha, values of the blend and base layers, independently for each color channel, R, G, and B. This is crucial to understand. Let's use the following notation. Asterisk CB, color of the base layer, R, G, or B component. Asterisk CS, color of the source/blend layer, R, G, or B component. Asterisk CR, color of the resultant layer, R, G, or B component. Important considerations asterisk. Asterisk normalization asterisk color values are often normalized to the range 0.0 to 1.0 before these calculations are performed. This simplifies the math. If your color values are in the 0 to 255 range, divide by 255 to normalize them. After the calculation, the result might be multiplied back by 255 to return to the 0 to 255 range for display. Asterisk clipping asterisk the calculated CR value may fall outside the valid range, 0.0 to 1.0 or 0 to 255. In these cases, the value is clipped to the nearest valid value. For example, if CR is calculated to be minus 0.1, it's clipped to 0.0. If it's 1.2, it's clipped to 1.0. 4. Blending mode categories and descriptions. Blending modes are generally grouped into categories based on their behavior and the types of effects they produce. Let's explore the common categories. A normal blending asterisk. Asterisk normal, or pass-through. This is the default blending mode. The source layer completely obscures the base layer where it's opaque. The formula is simple. CR equals CS, if alpha underscore S equals 1.0. CR equals CB, if alpha underscore S equals 0.0. If the source layer has partial transparency, the result is a blend based on the source alpha. CR equals CS asterisk alpha underscore S, plus CB asterisk 1 alpha underscore S. Asterisk dissolve asterisk. This blending mode creates a dithered effect, randomly replacing pixels from the base layer with pixels from the source layer based on the opacity of the source layer. The higher the opacity, the more pixels are replaced. It's not a true mathematical blend, but rather a visual effect. It doesn't usually have a defined formula, it's implemented using a random number generator. B. Darken blending asterisk. These modes generally result in darker colors because they compare the base and source colors and choose the darker of the two. Asterisk darken asterisk compares each color channel, R, G, B, of the base and source layers, and selects the darker value. CR equals min, CB, CS. Asterisk multiply asterisk multiplies the color values of the base and source layers. Because color values are typically normalized to the 0.0 to 1.0 range, multiplying them always results in a value that's equal to or darker than the original values. CR equals CB asterisk CS. This is excellent for casting shadows and creating realistic darkening effects. Asterisk color burn asterisk darkens the base color by increasing the contrast based on the source color. It produces richer, darker tones than multiply. The formula is more complex. CR equals 1, CB, slash CS, if CS, equals 0. CR equals 0, if CS equals 0. Notice the division by CS. If CS is close to 0, very dark, the result can be very dark. The burn effect is created by this increase in contrast. Asterisk linear burn asterisk darkens the base color to reflect the source color by decreasing the brightness. This is similar to color burn but creates a less saturated, more muted dark effect. CR equals CB plus CS, 1. If the result is less than 0, it's clipped to 0. See lighten blending asterisk. These modes generally result in lighter colors because they compare the base and source colors and choose the lighter of the two. Asterisk lighten asterisk compares each color channel, R, G, B, of the base and source layers, and selects the lighter value. CR equals max, CB, CS. Asterisk screen asterisk inverts the color values of both the base and source layers, multiplies them, and then inverts the result. This effectively adds the light from the two layers together. CR equals 1, CB, asterisk, 1, CS. This is a powerful mode for creating glows, highlights, and light leaks. It is the inverse of multiply. Asterisk color dodge asterisk brightens the base color to reflect the source color by decreasing the contrast. It's the opposite of color burn. CR equals CB slash 1, CS, if CS equals 1. CR equals 1, if CS equals 1. Notice the division by 1, CS. If CS is close to 1, very bright, the result can be very bright. Asterisk linear dodge, add brightens the base color to reflect the source color by increasing the brightness. This is a simple addition. CR equals CB plus CS. It can easily blow out highlights if the result exceeds 1.0. Excellent for creating bright, intense glows. D. Overlay blending asterisk. These modes combine aspects of both darkening and lightening, often based on the brightness of the base layer. Asterisk overlay asterisk multiplies or screens the colors, depending on the base color. Base colors lighter than 50% gray are lightened, while base colors darker than 50% gray are darkened. The source color is not replaced but is mixed with the base color to reflect the lightness or darkness of the base. If CB 0.5, CR equals 2 asterisk CB asterisk CS. Else, CR equals 1 to 2 asterisk 1, CB asterisk 1, CS. Overlay creates a strong contrast effect and is useful for adding texture and depth. Asterisk soft light asterisk similar to overlay, but the effect is more subtle. It uses a different formula to achieve a less harsh result. If CS 0.5, CR equals CB 1, 2 asterisk CS asterisk CB asterisk 1, CB. Else, CR equals CB plus 2 asterisk CS 1, asterisk D, CB, CB. Where D, CB, is defined as asterisk if CB equals 0.25, D, CB, equals 16 asterisk CB, 12, asterisk CB plus 4, asterisk CB. Asterisk else, D, CB, equals SQRT, CB. Soft light can add a soft glow or gentle darkening, depending on the source color. Asterisk hard light asterisk similar to overlay, but the roles of the base and source colors are reversed. It multiplies or screens the colors, depending on the source color. If CS 0.5, CR equals 2 asterisk CB asterisk CS. Else, CR equals 1 to 2 asterisk 1, CB, asterisk 1, CS. It is the same formula as overlay, but with the arguments flipped. This means that the effect is based on the light/dark of the source layer, rather than the base. Asterisk vivid light asterisk burns or dodges the colors by increasing or decreasing the contrast, depending on the source color. If CS 0.5, CR equals color burn, CB, 2 asterisk CS, / use color burn formula. Else, CR equals color dodge, CB, 2 asterisk, CS, 0.5, / use color dodge formula. Asterisk linear light asterisk burns or dodges the colors by increasing or decreasing the brightness, depending on the source color. If CS 0.5, CR equals linear burn, CB, 2 asterisk CS, / use linear burn formula. Else, CR equals linear dodge, CB, 2 asterisk, CS, 0.5, / use linear dodge / add formula. Asterisk pin light asterisk replaces the colors, depending on the source color. If the source color is lighter than 50% gray, pixels darker than the source color are replaced. If the source color is darker than 50% gray, pixels lighter than the source color are replaced. If CS 0.5, CR equals min, CB, 2 asterisk CS. Else, CR equals max, CB, 2 asterisk, CS, 0.5. Asterisk hard mix asterisk adds the red, green, and blue channel values of the source color to the red, green, and blue values of the base color. If the resulting sum for a channel is greater than 255, it receives a value of 255, otherwise, it receives a value of 0. As a result, all resultant colors are pure red, green, blue, yellow, magenta, cyan, white, or black. This mode creates extremely posterized, stark color effects. CR equals, CB plus CS 1.0, 1.0, 0.0 / after normalization. E-difference blending asterisk. These modes calculate the difference between the base and source colors, resulting in often unusual and visually striking effects. Asterisk difference asterisk subtracts the darker of the two color values, base or source, from the lighter one. CR equals ABS, CB, CS. This is useful for finding subtle differences between images or creating abstract color effects. Asterisk exclusion asterisk similar to difference, but the effect is less extreme. CR equals CB plus CS, 2 asterisk CB asterisk CS. Asterisk subtracts the source color from the base color. CR equals CB, CS. Results can be negative, so the result is clipped to 0.0. Asterisk divides the base color by the source color. CR equals CB/CS. Careful. Dividing by 0 can cause problems. F composite blending asterisk. Asterisk add, aka linear dodge as explained in lighten modes, this simply adds the color values together. CR equals CB plus CS. G color blending asterisk. These modes affect specific aspects of the base color based on the source color, such as hue, saturation, color, and luminosity. Asterisk hue asterisk replaces the hue of the base color with the hue of the source color, while keeping the saturation and luminosity of the base color. A complex operation involving conversion between color spaces, typically RGB to HSL or HSV. Asterisk saturation asterisk replaces the saturation of the base color with the saturation of the source color, while keeping the hue and luminosity of the base color. Also a complex color space conversion. Asterisk color asterisk replaces both the hue and saturation of the base color with the hue and saturation of the source color, while keeping the luminosity of the base color. This is often used for colorizing black and white images. You're transferring the color information from the source to the base, but preserving the lightness and darkness of the original. Asterisk luminosity asterisk replaces the luminosity of the base color with the luminosity of the source color, while keeping the hue and saturation of the base color. This can be useful for adjusting the brightness without affecting the color. V blending modes in Adobe After Effects and Premiere Pro. Adobe After Effects and Premiere Pro offer a consistent set of blending modes, accessible through the Mode drop-down menu in the Timeline panel. Here's how you can use them effectively. Asterisk accessing blending modes asterisk in the Timeline panel, select the layer you want to apply the blending mode to. Then, use the Mode drop-down to choose the desired blending mode. If you don't see the Mode column, click the Toggle Switches/Modes button at the bottom of the Timeline panel. Asterisk opacity control asterisk the opacity property of a layer directly affects the intensity of the blending mode. Lowering the opacity will reduce the effect of the blending mode. Asterisk layer order matters asterisk the order of your layers is critical. The blend layer must be above the base layer, S, in the Timeline panel for the blending mode to take effect. Asterisk nested compositions asterisk you can pre-compose layers and then apply blending modes to the pre-composition as a whole, allowing you to create complex visual effects. Asterisk adjustment layers asterisk use adjustment layers with blending modes to apply effects to multiple layers simultaneously. This is a non-destructive way to experiment with different looks. Asterisk track mattes asterisk blending modes work in conjunction with track mattes. A track matte allows you to use the luminance or color of one layer to control the transparency of another. 6. Blending modes in Film Riot tutorials. Ryan Connolly of Film Riot often demonstrates clever uses of blending modes in their tutorials. Here are some common techniques and examples. Creating light leaks and flares. Film Riot frequently demonstrates how to create realistic-looking light leaks and lens flares using stock footage, textures, or generated elements, like fractal noise, and applying blending modes like screen, add, or overlay. They will often use multiple layers and blending modes to achieve a complex, layered effect. The key is to start with a bright, high contrast element and then use the blending mode to integrate it seamlessly into the scene. Texturing and grunge. Blending modes like multiply and overlay are excellent for adding texture and grunge to video footage. Film Riot might use textures of paper, concrete, or scratches, and then apply one of these blending modes to create a distressed look. They might also adjust the opacity of the texture layer to fine-tune the effect. Color grading and looks. Blending modes can be used for subtle or dramatic color grading. For example, you can create a color solid layer, solid color, and then apply blending modes like color, hue, or soft light to subtly shift the color palette of your footage. This is a quick way to experiment with different moods and styles. Creating shadows. Use multiply blending mode to create realistic shadows. Create a shape, example using the pen tool, to represent the shadow. Fill it with a dark gray or black color. Apply the multiply blending mode to the shape layer. Adjust the opacity and position of the shadow to match the lighting in your scene. Isolating highlights. Create a duplicate of your footage. Use curves or levels to push the image to be mostly black except for the brightest highlights. Apply the screen or add blending mode to this layer. This will enhance the highlights and give a subtle glow. 7. Code examples, implementing blending modes with Python and Pillow, PIL. Let's explore how to implement some basic blending modes using Python and the Pillow, PIL, image processing library. This will give you a deeper understanding of the underlying math. Explanation. 1. Import libraries. Import Pillow for image processing and NumPy for array manipulation. 2. Normalize _color, and denormalize _color, functions to convert color values between the 0 to 255 range and the 0.0 to 1.0 range. 3. Multiply _blend, screen _blend, overlay _blend, functions to implement the formulas for the multiply, screen, and overlay blending modes. These operate on single color values. 4. Apply _blend _mode, opens the base and blend images using Pillow. Crucially converts them to RGBA mode to handle alpha channels. Resizes the blend image to match the base image. Converts both images to NumPy arrays of floating point numbers, using np.float32. This is essential for accurate blending calculations. Using integers would lead to significant rounding errors and incorrect results. Normalizes the color values by dividing by 255.0. Creates an output array of the same size and data type as the base image. Iterates through each pixel of the images. Applies the specified blending mode to each color channel, R, G, B, of the pixel. The alpha channel from the blend image is passed through, preserving the transparency of the blending layer. The blending modes only affect the color channels. Clips the output values to the range 0.0 to 1.0 using np.clip. Denormalizes the blended pixel values by multiplying by 255. Converts the output array back to an 8-bit unsigned integer array, np.uint8. Creates a Pillow image from the blended data. Saves the blended image. 5 Example usage * shows how to use the apply_blend_mode function with different images and blending modes. To run the code * 1. Install libraries * pip install pillow numpy. 2. Prepare images * create 2 PNG images named base.png and blend.png and place them in the same directory as your Python script. Make sure blend.png has some transparent areas to see the blending effect clearly. 3. Run the script * execute the Python script. It will generate output_multiply.png, output_screen.png, and output_overlay.png in the same directory, showing the results of applying the different blending modes. Key improvements and explanations *. RGBA handling * the code now correctly handles images with alpha channels. The alpha channel from the blend image is preserved. This is critical for many compositing tasks. Data type * the code uses np.float32 for the number pi arrays. This is essential for accurate blending calculations, preventing significant rounding errors that occur when using integer types. Normalization and denormalization * the code properly normalizes the color values to the range 0.0 to 1.0 before the calculations and then denormalizes them back to the range 0 to 255 for the output image. This is crucial for getting the correct results. Pixel by pixel iteration * while the code demonstrates the core logic using pixel by pixel iteration, you could significantly speed up the process by using NumPy's vectorized operations to perform the blending calculations on the entire image array at once. Error handling * includes basic try, except blocks to catch potential errors, such as file not found or invalid blending modes. Readability * the code is structured with clear function definitions and comments to make it easier to understand. 8. Practical tips and tricks. Experiment. The best way to learn blending modes is to experiment with them. Try different combinations of blending modes and layers to see what effects you can create. Start subtle * don't overdo it. Often, the most effective use of blending modes is to create subtle enhancements rather than dramatic transformations. Consider opacity * adjust the opacity of the blend layer to control the intensity of the blending mode. Use adjustment layers * apply blending modes to adjustment layers to affect multiple layers simultaneously. This is a non-destructive way to experiment. Think about color * pay attention to the colors of the base and blend layers. The colors will have a significant impact on the final result. Use mattes * combine blending modes with track mattes for more complex and controlled effects. Precompose * precompose layers to group them and then apply blending modes to the precomposition. Understand the math * while you don't need to memorize all the formulas, understanding the basic principles behind each blending mode will help you predict the results and troubleshoot problems. 9. Conclusion. Blending modes are powerful tools for creating a wide range of visual effects in video and film. By understanding the underlying principles and experimenting with different techniques, you can unlock a whole new level of creativity in your work. From subtle color grading to dramatic visual effects, blending modes can help you achieve the look and feel you desire. This tutorial provides a foundation for understanding and using blending modes effectively in Adobe After Effects, Premiere Pro, and even in custom scripting environments using libraries like Pillow and NumPy. Practice, experiment, and have fun. And remember to watch Film Riot for inspiration and practical tips.